Next, we're going to look at how to design a workload so that it runs effectively on a cluster. As we've seen before by studying Amdahl's law, if we know some basic properties of an application, we can make some predictions about how it's going to perform. But this is really important. In order to do this, first you need to know some basic facts about your workload. And these things are often easy to overlook when you're using a single computer. If you sit down at a laptop and you type some command in it and it works, you may not know a lot about that command, such as how much I/O it does or how long it runs, and you may not care as long as it runs on your laptop. But if you're going to scale up to millions and millions of tasks running on thousands of cores, you can't predict or understand what's going to happen unless you first know some basic facts about your application. So, know your workload. If you're going to scale up, here's some basic things that you need to figure out before you start submitting things to a batch system. So first of all, roughly how many tasks do you want to run? Is it 10? Is it 1,000? Is it 1,000,000? And how long do you expect each of those tasks to run? Is it a short little data analysis script that's going to complete in 30 seconds? Or is it a long simulation that's going to run for an hour? You can test these things out by running one or two applications first by hand to see what happens. Next thing, how big are the files? Again, it's not hard to figure out, but unless you explicitly go in and use some tools to look at the size of the files, you're not going to know whether your files are a kilobyte or a megabyte or a gigabyte or a terabyte. And the difference between those things is many orders of magnitude, and therefore many orders of magnitude in the scalability of application you're going to be able to run. Now this one's a little more tricky. It's important to know which of your files are shared among tasks. Now what do I mean by that? Oftentimes you'll have an application that reads in some unique input and produces some unique output. And if you had many tasks that each have their own unique outputs, then they each have to get different bits of data. But sometimes you have a piece of data or a large file that's needed by all of your tasks, and that we would call a shared file. And it presents some challenges as well as opportunities in how you schedule your workload, which we're going to see next.